Hello and welcome to the 2021 University of Memphis Advanced Robotics Class Final Demonstrations. My name is Kevin Barisso. We will have two demos for you today, but before we begin, I would like to thank Yaskawa for the generous donation of the HC10 collaborative robot you are about to see. We also need to thank Eaton for the generous donation of the step-up transformer that allows us to power this robot. And so without further ado, here's our first demo.
Are we good?
We should be good.
Cool. All right. Hello, everyone. My name is Matt Hale. This is my robotics project. So we're using the Yaskawa HC10 to do some machine tending. So what that means is that we're essentially setting up the robot in front of a CNC machine and having it load in parts and then take out the good parts. And hopefully they're good parts. As you can probably see, we don't really have a CNC machine up here. So we kind of mocked one up, and Jacob's going to be running, acting as our lathe today. So the robot will be loading in the stock, and then Jacob will take out the stock, put in the finished part as if it was being machined. So that's how we're working around that. What I've got right here is this Kanban cart. So it's loaded with 9 pieces of stock. And I'm going to load it into the slot for the cart, and it's going to run hopefully all 9 parts. The reason that we're doing this is so that we can control production, and also so that if we wanted to switch over to a different part, we can do that very easily, simply just by loading up a different cart and then choosing a different program. So I'm going to go ahead and put it in its spot, hopefully. I'm going to lock it in place. And we will get this started. So what you'll see is the robot will be loading in that stock into the chuck. And then as the lathe is operating, it's going to actually come over and pick up another part. So it's going to be doing operations as the lathe would be machining the part. Here in a second, you'll actually see it take the good part, and it's going to take it over to the quality check area. So it's going to check for the diameter of the inner circle that was machined. You'll see over here on the screen, you're seeing what the camera is looking at. So it's going to take it over to that camera right now. It's going to take a picture. And if it's green, says affirmative, it's a good part. If it's red and says negative, it's a bad part. So since it's a good part, it's going to put it over on the cart for the good parts. And it's just going to keep on doing this. So you might notice that it's running kind of slow. That's because the HC10 is actually a collaborative robot. So that means if it comes across, if it hits something that it shouldn't, then it's going to stop. So it's safe to work around people without needing any sort of safety fencing or anything. So that means if I'm in here, trying to work on something and the robot comes over to me, it's going to stop. And I can just hit this button and it'll pick back up. So it works a little bit slower, but it's a lot safer. So this is a bad part. So it's actually going to take it over and toss it in this bin over here. So this next part that it's going to pick up is a great example of why the quality control is so important. Because whenever you're doing stuff like this, if a tool breaks, the machine's just going to keep on going and act like nothing's wrong. So you're just going to be making a bunch of bad parts. So on this part, there's not even a hole. There's a center hole, but the drill didn't go through, which is not good at all. So obviously a drill broke in the lathe. And if we didn't have this quality control right here, you'd never know. So it comes up as a bad part. The other thing is, since we're only doing 9 parts, if it were to register another bad part, so that'd be 3, then it's going to automatically shut down. It's going to send a warning to the teach pendant and basically tell the operator to check the tooling. Something's wrong with the tooling. So it won't allow you to make continuously bad parts. So that's the other cool thing about the collaborative robots is that if something were to go wrong, like this right here, then it's not going to break the machine. So in a different robot, this would just go straight through this cart. It'd break tooling. You'd be running into so many issues. But since it's collaborative, it detected that something went wrong. It's getting more feedback than it should. So then the operator can just come in here and simply press this button. And everything's fine. There's no real issues at all. If I were to remake this, I'd make these these holders just a little bit larger so that error doesn't happen. But again, since it's collaborative, there's no problem really at all. There's no damage being done, so that's totally fine. But other than that, I think that's it. Thank you to Jacob for acting as our lathe today. I appreciate it.
All right. I'm going to turn off the controller unless there's a reason to leave it on. Then I'm going to let people ask questions.
Okay.
So hang on to the mic. So this way you can hear us.
Yeah, hearing would be nice.
So go ahead and tell them that you can ask questions if you want.
All right, y'all can ask questions if you have any. Hopefully I'll be able to answer them.
Hey Matt, it's Scott.
Hey, Scott.
I'm using the old laptop. Look at this video. It's terrible. So anyway, I might make me look better. I don't know. My question was, did you do all the integration on this using the IO on the robot controller, or have you got a PLC in the system, or how are you doing it?
Yeah, so we're running everything through the PLC, which is the one area of this project that I am nowhere near good at. So Kevin actually helped me a lot with that, with just connecting those IO points. So I just let him know what I needed, and he was able to connect all those dots and everything for me. So.
Yeah, you got a lot of fabrication in this project.
Yeah, it was a lot of fabrication. Everything, the cart, the lathe, all this stuff was, except for like the robots and the cameras and things like that, was made by me. So it's been quite a project, to say the least.
Nice job.
Thank you.
Pull back far enough so they can see.
Yeah.
Hey, Matt, I had a question here. Clint Chapman from Yaskawa. Great.
Oh,
great
yeah, I can
job.
hear you. Sorry.
Okay, great job on the interface. And what you have just worked on is the quintessential project for, I would say, at 99% of the machine tool industry, is how to transfer. So it's a great project. It's completely applicable to what's happening in the workforce right now today. So good job. Nice selection of project.
Thank you.
What would you say? Yeah, no problem. What would you say was the biggest hurdle for you? I mean, obviously you had to build your own mock CNC tool. So that was a hurdle in itself. But I mean, as far as getting the machine to do the job that you're trying to prove, what was the hardest thing in that realm?
Yeah, that's a tough one. There were a lot of difficulties. One being the fact that this is a brand new robot for me and Kevin. Yaskawa is, at least I've never messed with them. I don't think Kevin really has. At least not the HC10. So I had to learn sort of the different ways of programming. I'm used to the Fanics and the Mitsubishis, so I'm familiar with at least programming, but getting used to that different interface. I think the hardest part was actually just finding the right part to make, honestly, because we wanted something that we could easily do some quality control on, easily pick up and place and everything, but also not so difficult that it makes it too much of a challenge. I think locating the cart was probably the most difficult, because it's super critical. If the cart isn't properly located, then everything's going to go wrong. So I used a lot of offsets. I trusted the CAD work that I did, which ended up working out pretty well. So this is definitely a project that the more thought that went into the planning, the easier it was to execute, and that was super evident. So I think I was lucky that it went as smoothly as it did. I think it could have gone a lot worse. So
Part placement in relationship to the robot, and that relationship to the collet or the chuck in the tool itself is a critical factor to get product through the system. Have you thought about other ways of locating the cart, or other ways of maintaining that relationship between the robot and the array of parts being presented?
yeah, absolutely. What I would love to do is set up another camera up higher, to where no matter where the cart is at, it's locating the parts. So the cart could come in skewed, honestly, and it would still be able to locate each part and then provide offsets to the robot that way. We're limited with what we had available. So I think that using the camera for the quality control was more important here. Obviously we were able to locate the cart, well enough using it this way. But if it were me implementing this in a facility, I would want to set up a camera that locates the cart or the parts on the cart. That way we're getting as accurate data as we possibly can. That would be, I think, the ideal situation for me.
Fantastic. So integrating a vision system with material handling is absolutely critical, and I think you've gone through that. Was there any way to broaden the view of the current camera system to incorporate both operations, meaning QC check and also cart placement?
Technically, yes. In fact, like we had originally planned to have 2 different quality checks, one for length and also for the hole. After talking to Kevin about it, I think we decided that with the Cognex system, it would have taken a little too much time to run both programs. So I really would just wanted to stick to the single program, but that could be done. I think it would just slow down the process a little bit. And since if we had an actual lathe, I think we could get away with it because you're going to have machine time. But since nothing's happening with our mock-up lathe as it is, I kind of didn't want us to just sit there for like 2 minutes and just, yeah, so it's machining right now. So yeah. So to kind of speed up the process of just this example, I just wanted to stick with the one operation or that one program on the camera, but it is possible to run 2. That'd be interesting to see about using it both as a locator and as that quality control.
Well, great project, Matt, and congratulations. It looks great.
Thank you so much.
Matt, when did you guys get these the Dale here? How long has Dale been powered up?
How long has he been powered up?
I mean, yeah, when did y'all get him in and mounted and start working with him? It's been what, 2 months maybe tops?
I don't know. Early February. Yeah, early February.
Yeah.
This whole semester has been kind of a blur.
Yeah. Okay.
So, last week, I don't know.
Yeah, it's well, you had kind of a steep learning curve there in short time to do it. And
yeah, absolutely. I mean, there were so many things. I mean, the just getting power to these robots was, an issue. So it's just been. I mean, we're so glad that we have them, but it's definitely been a process to get to where we're at right now. So definitely happy that we were able to get through all that and put together a project that actually works. Chris?
How difficult was it programming the collaborative robots and the more traditional?
So not that different. Sorry. So Chris asked how different it was to program the collaborative robot versus a traditional robot. We have the Fanix in here, and it's not that much different. I think that the issue with me was just learning the different language that Yaskawa uses. But as far as the collaborative side of things, not hard at all. It's kind of they make it pretty easy to work with. And the manual explains, if you run into this situation, do this. So they make it as easy as I think you possibly could. Are there any other questions?
Yes, this is Steve Holland from Yaskawa Academy. I just wanted to kind of ask the same question, but kind of a different spin. So you indicated that you're a prior robot programmer. So how easy was it for you to transition from brand XYZ to Yaskawa Pendant?
It took maybe an hour to get comfortable with it. Just just learning or figuring out the different methods of like teaching a point, how to change that point to a linear movement, how to set variables and have positions that I could call. But other than that, once all that was figured out and just those small details, I could connect in my head of like, I want to do this. Oh, that's right. I have to go here and do that. It was seamless. And I was programming for a couple of days, and after that, I felt super comfortable with going through and editing programs. And I was even able to go and without flipping through a manual or going to Google or anything, figuring out how to run background programs, things that I would want to do but didn't really quite know how. I was able to figure it out just by using the Teach Pendant. So it was really a seamless transition, at least for me. I really it could have been a lot more difficult to learn the different language, but it was actually pretty easy.
Okay, well, great. And have you ever attended a formal programming class?
I've taken automation or robotics here in undergrad, and then advanced robotics this class for this is taken as a grad class for me.
Okay.
So just those two classes, and then for ET we have a little background in C++ programming, so we get a little bit of at least kind of the background knowledge of how to really think in terms of programming, and then just a couple of classes of hands-on experience with robotics.
Okay, well, great. Well, great job. Thank you.
Thank you.
Okay, and kind of to further elaborate a little bit on Matt's last comments, and Steve's question there. I went to the Yaskawa Academy last week for the training on this controller. So everything that Matt did, everything I was able to show him earlier in the semester, like he was saying, was truly look at the manual, maybe a YouTube video or two. But yeah, Yaskawa has done a great job of making everything reasonably intuitive, and there wasn't a huge learning curve there, which was wonderful. So yeah, Matt's done a great job. We are going to switch over. I apologize for the lousy camera work as well, but we're going to roll the camera over to the other side of the lab and do the next demo here in a minute or two.
Good morning, everybody. My name is Jacob Tidwell, and today I'm going to be running a pick and place program with the FANUC M1IA robot. It's essentially just a marble run, but the robot's going to be picking and placing marbles onto designated pallets that are read by an ID reader that tells how many marbles to load onto the pallet. Okay. So what has happened is there's not enough product to load onto the pallet. I have a machine vision looking at the pallets, ensuring that they get loaded properly after each load cycle. And if it's not, red light comes on, the conveyor stops, and the person operating the system or the person standing by can say, hey, something's wrong. Come take a look over here. It's obviously not loaded correctly. We can fix it. Inspect this. Everything looks fine. Hit the reset button. You ready to go? Yeah, it pretty much just continually does this the whole time, you know? Oh. Looks as if my machine vision camera has got off track. Now to see if the camera is actually looking correctly, you can come over to the, it's connected to the computer next to it. Just slightly off. Definitely for 5 pallet though. But overall, it's pretty much my project. I designed the whole track layout and the tank over here, and drew schematics up, got them to people that knew how to print them out, you know? But yeah, that's it. Does anybody have any questions? Hey.
How does the robot determine how many marbles to put in each? How does the robot determine how many marbles to put in each pallet? I look at the pallets and I see that there's different setups in there.
Absolutely. So how does the robot determine which pallet is which? You have a certain combination right here. It's 3 different screws for, well, 3 different places to put screws. Each one has different combination. When it comes into the loader, the ID reader will read that specific combination and send that info back to the PLC, and then PLC will say, hey, load this. This is the ID reader. It comes out and reads right on the edge. Any other questions? All right.